Hey guys, all right. This is gonna be the notes to the product rule. Um, so this is after note card 18, okay? I'm sorry, note card 17. So the first question it's asking for the derivative of 5x cubed times sine of x. Okay, so obviously it's product rule because we have two functions be multiplied to each other. So we're gonna take the derivative of the first, which is 15x squared, times this the original, the second, plus the first times the derivative of the second, which is cosine x. Now, you can actually simplify this or actually rewrite this by factoring out, but we're going to go ahead and carry on just for time's sake, okay? The next one says, given that m of x, p of x, and h of x are differentiable functions, and p of negative 3 is equal to 4, h of negative 3 is equal to 2, p prime of negative 3 is equal to 1/5, and h prime of negative 3 is equal to negative 2/3. Find the slope of the tangent line to m of x at x equals negative 3. Given that m of x is equal to negative 2 h of x times p of x. So we want to know just the slope of this. So basically we need to take the derivative of m, then plug in negative 3. So here's the formula that we have here. So we're going to take the derivative of that, which requires us to use the product rule again. So it's going to be negative 2h prime of x, that's the derivative of the first, times the second, plus rewriting the first times the derivative of the second, okay? So we're going to go ahead and, just for notation, so that we can have it a little organized, I'm going to plug in negative 3, so it's going to be negative 2h prime of negative 3 times p of negative 3, and this becomes a minus 2 h of negative 3 times p prime of negative 3. So if we look at these values up here that we have, h prime of negative 3 is equal to negative 2/3. P of negative 3 is equal to 4, so times 4, minus 2, h of negative 3 is equal to 2, so times 2, times p prime of negative 3 is equal to 1/5, so times 1/5. So here we can basically simplify a little bit further. So negative 2 times negative 2 is 4. 4 times 4 is 16 over 3. And then negative 2 times 2 is negative 4 times 1 is negative 4, so it's going to be minus 4 over 5. And then we can just combine these by multiplying this by 5 over 5, this one by 3 over 3. So we get 80 over 3 minus 12 over 15. Sorry, this is a 15 here. 15. And this turns out to be 68 over 15. So this is the slope of m of x at x equals negative 3. So the tangent line that's at x equals negative 3. Okay. All right, the third one's asking for the instantaneous rate of change. So the IROC of this function s of t is equal to 4t squared. Let me rewrite this over here. I'm sorry because I don't have enough space. So s of t is equal to 4t squared minus 2 sine of t plus pi. And they want the instantaneous rate of change at t equals to negative pi over 2. So s prime of t, we're going to take the derivative because instantaneous rate of change means we're going to take the derivative and plug in negative pi over 2. So we're going to get 8t, the derivative of that, and the derivative of this is going to be negative 2 cosine of t, and then the derivative of this is just 0. So we're going to plug in negative pi over 2 now. So we're going to get 8 times negative pi over 2 minus 2 cosine of negative pi over 2. Okay, so here when we multiply this out, we can simplify this. This reduces to a 4 and this reduces to a 1, so we get equals to negative 4 pi. And here, cosine of negative pi, just remember on the unit circle, negative means we're going clockwise. So here we want to know the x coordinate, the x value there, which is 0. So here, all this becomes 0, so our answer is just negative 4 pi. Okay, and the last question is is asking for the equation of the normal line. So here I'm going to put that we need a point and a slope. For any line, we're going to need a point and a slope to create that line. So just here on as a subscript, I'm going to put n so that I remember that I need to get the normal which is perpendicular to the tangent. So here I have the function g of x. So I want the normal line to this function g of x, which is 3x minus 2 cosine of x at x equals pi. So I'm going to need to substitute this back in here. So g prime of x, when I take the derivative, I'm going to plug in pi. So here's the derivative. It's going to be 3 plus 2 sine, because the derivative of cosine is a negative sign. It turns into a positive here. And then let's go ahead and plug in pi. So it's going to be 3 plus 2 sine of pi. And then remember, on the unit circle, here's pi coming this way. My y value is 0 there. So this becomes 0. My answer is just 3. So my slope for this one, since this is for the tangent, is going to be negative 1/3 when we take the opposite reciprocal. So here we already have the x coordinate here, because that's what's given to us. Now to find the y, I need to plug it into the original. So g of pi is equal to 3 pi minus 2 cosine of pi. Cosine of pi is negative 1, because that's what the x value is there. So negative 1 times negative 2 is a positive 1, so we get 3 pi plus 1. So that's your x value, 3 pi plus 1. So now if we want to go ahead and write this as an equation, we're going to get y minus the y value that we have here in parentheses, minus 1, 3 pi minus, plus 1, I'm sorry, is equal to the slope, negative 1/3, times x minus pi. So this is the equation of the line that's normal to this equation at x equals pi. Okay.